Hello and welcome to this week's episode of the fun, sort of, chemistry show. Today we'll be learning about the super exciting concept of electron configuration. Woo! Since you're so excited to learn about this, let's get started.
Electron configuration is the way in which electrons are arranged in various orbitals around the nucleus of an atom. So what? Well, electron configuration is important because it's so important to know how electrons are arranged around a nucleus of an atom.
Orbitals are the region an electron occupies. There's four main orbitals, s, p, d, and f, which all have different shapes. The s orbital is a spherical shape. The p orbital is a dumbbell shape. The d orbital is a cloverleaf shape. The f orbital is four-dimensional and cannot be drawn on paper.
There are three specific rules to follow when doing electron configuration. The first one is off-bow principle. This states that electrons occupy orbitals of lowest energy first. The second one is the Pauli exclusion principle, which says that an atomic orbital can only hold two electrons, and the electrons don't like to share orbitals unless they have to. The last one is Hund's rule, which states that electrons within orbitals spin in opposite directions.
Before we move on, you should know how to draw out the electron configuration for an element. The periodic table can be split into four blocks, one for each orbital. The yellow group is the s block. This group is the p block. This group is the d block. And this group is the f block. The group corresponds to which block it is in, and the period corresponds to the energy level of each orbital.
This is how to do the electron configuration for magnesium. Start with the hydrogen and list out each energy level and orbital group in order up to the desired element. Remember that for the d block, the coefficient is one less than the actual period number.
This spot is the 1s2 spot. This spot is the 2s2 spot. This spot is the 2p6 spot. This is 3s2. This spot is 3p6. This spot is 4s2. And lastly, 3d2.
Let's try another example. When doing the electron configuration for an atom like silver, it is important to note that the coefficient, or the number in front of the orbital group, drops from 4s2 to 3d10. This is because only for the d block, the coefficient is one less than the actual period number. The electron configuration for silver is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, and 4d9.
In the case of an element such as barium, instead of writing the entire electron configuration, which can take a lot of time, you can make it simpler by using noble gas configuration. To do this, start at the noble gas in the period above your element and put the noble gas symbol into brackets. From there, continue the electron configuration until you reach your element.
Thanks for watching the
Fun, sort of, Chem Show!